Okay, so I want to show another way of balancing chemical equations so that you don't need to draw a model every time. So first, when I look at a chemical equation, we need to be able to count how many atoms are in a formula. So the way we're going to do that is I'm going to kind of just show you really quick using this model. So starting with 5H2O. What this means is I have 5 molecules of H2O. So I'm going to draw it like this, HOH. But I'm going to need to have 5 of those. So I'm going to do, there's 1, 2, 3, 4, 5. So I have 5 of these molecules. All right. So how many hydrogens do I have? I can just count really quick. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice I have 5 sets of 2. Well, in algebra or in elementary school math, you learn that 5 sets of 2 is just multiplying. So what I'm going to do is I'm going to take 5 times 2, and I'm going to get 10. So I have 10 hydrogen atoms. All right, because I have 5 times 2. I'm taking 5 times 2. Okay. So I'm going to undo that. And then let's see, what about the oxygens then? Well, for the oxygens, I have 5. I'm going to take 5 times 1. Well, 5 times 1 is 5, so I have 5 oxygen atoms. Okay, so we don't have to actually draw the whole formula. We just need to multiply. Okay. What about if I have something like this? Oftentimes in a chemical reaction, we'll have more than one substance on each side. So I can count. So let's look at what elements I have. So first I have carbon. Let's do carbon in orange or whatever color this is. Kind of looks like a reddish color. All right. So for carbon, I can do 3 times 1. I have 3 carbon dioxide molecules. So I have 3 times 1. I have 3 carbon atoms. All right. Hydrogen. Hydrogen is pretty easy. Let's do hydrogen in blue. So hydrogen, I'm going to do 4 times 2. 4 times 2 is 8 hydrogen atoms. Okay. And then the one that people are going to struggle with this one, and this is really where most people have a hard time with, is if you have oxygen in 2 different compounds. Notice that I have oxygen over here, and I have oxygen over here. Right? So the math, we're just going to add those 2 things together. But I just have to follow my math rules. So for oxygen, I have 3 times 2 plus 4 times 1. Okay, so that's going to equal 6. I'll get a little bit bigger so you guys can see. Running out of room, sorry. 6 plus 4. I have 10 oxygen. Okay, excuse me. So remember, if you have more than one, you're going to add, this is 3 times 2, you do that first. And then you do 4 times 1. Well, 3 times 2 is 6, plus 4 is 10. Right? So I have 10 oxygen atoms here. I have 3 carbon, 8 hydrogen, and 10 oxygen. Okay, so that's that one. Same idea over here. I'm going to probably do less writing over here now. For aluminum, I'm going to do 6 times 2 equals 12. I have 12 aluminum atoms. I have sulfur. Okay, so here's something a little bit new. So notice that we have sulfur inside these parentheses. All right, so the way we're going to deal with those parentheses is we're going to just multiply again. So what this means is this 3 means I have 3 sets of the SO4. So that means there's 3 SO4s, but then over here I have 6 molecules of Al2SO4, 3. So for the sulfur, we're going to do 6 times 1, because there's a little 1 there, times 3. So we're going to get 6 times 1 times 3 is 18. So I have 18 sulfur atoms. And then for oxygen, same idea. We have 6 times 4, because there's a little 4 here, times 3. And then we're going to get, I'm actually doing my calculator because my brain's farting. We're going to have 72 oxygens. For this year, you're probably not going to see a whole lot of those where you have to deal with parentheses. But there you go. You just have to multiply twice for those. Okay, so that's counting atoms without having to draw molecules each time. All right, so how does this apply then to balancing chemical equations? So remember, when we're balancing chemical equations, we're only going to be changing the coefficients because we're changing the number of molecules on each side, but we can't change the formula itself. So when I do something like this, what I like to do, this is a super simple one. You don't need this chart. This chart is just to help to keep track. I'm going to make myself a little chart, and in this chart, I'm going to write the individual elements. Each different element is going to have its own space. But on the left side, I'm going to write my reactants. So here, notice I'm drawing my chart right in the middle so that I can count left and right. Right? I might even just use left and right instead of reactants products, but I kind of tend to interchange them. Right? So I'm going to write my reactants, just keeping track, and my products here. So this is just a way, this chart is just a way for me to keep track. So using the same tools that I just taught you, on the left side over here, we have 1 sodium and 2 chlorines, because it's 1 times 2 and 1 times 1. So I have 1 sodium and 2 chlorines on my reactant side, or on my left side. And on the other side, on my product side, I have 1 times 1 for sodium and 1 times 1 for chlorine. So I have 1 of each. So this makes it super easy then to tell what's balanced and what's not balanced. Because if I look at my numbers, here right now it looks like my sodium is balanced, but my chlorine is not. So what I want to do then is I want to change my coefficients to make chlorine balanced. So I'm going to ask myself, what number here, what coefficient can I do to make my chlorine equal the other side? So my other side says 2. So I'm asking, what times 1 equals 2? Well, this is a super easy one, 2. So that allows me to change my numbers. But I have to make sure I change everything. So once I put that in there, that's going to change my sodium to 2 now, because 2 times 1. And chlorine is now 2 because 2 times 1. So that helped me by fixing and balancing my chlorines. But unfortunately, it unbalanced my sodiums. So what I need to do now, as I see that my sodiums are not balanced, is I'm going to go ahead and change a number again. So my next thing I'm going to do is I'm going to put a 2 here, because 2 times 1 gives me 2. Notice again, I'm changing my coefficients, and the chart is just a way for me to keep track. Right? So now everything's balanced. I have my sodium balanced, I have my chlorine balanced. It's quick and easy to see. That is now a balanced chemical equation. Okay, let's try another one. Same idea. I'm going to make that a little bit bigger so we have some space to write. Or maybe not. All right. So here what I'm going to do is every time I do this, and until you get used to it and you guys can do it in your head, I strongly suggest writing a chart. And I like a chart like right below my chemical equation. Some people like to just write the elements out individually and say left, right. Okay, so looking here, the elements I have are sodium, Na. I have hydrogen, and I have oxygen. All right. So counting my sodiums, I have 1 sodium on the left, 1 sodium on the right. I have 2 hydrogens on the left, 2 hydrogens on the right. It's looking good so far. And on the left, I have 1 oxygen. And on the right, I have 1 oxygen. So this looks like it's balanced. Let me double check my counting just to make sure. So I'm going to use my cursor. So 1 sodium, check. 2 hydrogen, check. 1 oxygen, check. Over here, I have 1 sodium, 1 oxygen. Oh, I have 3. So my hydrogen I miscounted. So what I need to do is I need to change this. And I see that I forgot about this hydrogen. So I actually have 3 hydrogen on this side. All right. So this becomes kind of a little bit difficult because I have to decide what number I want to change. And it looks to me like I need more hydrogens on this side. But I can only multiply by 2. There's no number 2 that I can number, There is no number that I can multiply by 2 to get 3. That's a whole number. Remember, we want these to be whole numbers. There are tricks I can play with fractions, but I'm going to leave those for you asking me questions as you need to. So what I'm going to do then is I'm going to realize I'm going to go ahead and just increase this by 1. I'm going to make that a 2, which is going to change my hydrogens to 4, because 2 times 1, and it's going to change my oxygens to 2. All right. And I need to realize that I need a whole number here. So I could change any numbers here, but that's going to increase it. If I make that 2, it's going to increase it by 2. All right. The easiest way in this case is I'm going to add a 2 here, because 2 times 1 is 2. And then I already have 2 here. So that allows me to increase just by 1. So now I have 4 hydrogens, but that changes my sodium to 2, and it also changes my oxygen to 2. Oh, but look, that actually helped me. It kind of fixed my oxygen already. And an easy fix to fix my sodium is just to change this to a 2. Boom, I'm done. Okay, don't be afraid to go back and forth. These are essentially just puzzles. Every one of them is a puzzle. They should work. There's always one that works. If it's not working, that means you probably copied down something wrong on the formula. Now, one thing I also sometimes get with students is, what about this number? Remember, that's a 1 here. If you want to put a 1 in there, then you can, but you don't need to. It's implied that there's a 1 there. All right, let's do one more. So for this one, again, I'm going to write my chart. I have K, I have Cl, and I have O. On my left side, I have 1 K, 1 Cl, and 3 Os. On my right side, I have 1 K, 1 Cl, and 2 Os. Okay. So looking at this really quickly now, my Ks are balanced, my Cls are balanced, but my Os are not. If I say, okay, so I need more on this side, well, what times 2 equals 3? Oh, there's nothing times 2 that's going to give me 3, and there's only one number over here. So here I want to think about my least common multiple. What can I multiply by 2 by to get 3? Kind of an easy way to solve this is I'm going to take this and I'm going to multiply it by that. I'm going to multiply it by the other number. So I'm going to take, and I'm going to just put a 3 here, which will obviously make this 6. And then because I changed that to 6, I want this to be 6. I want this to be 6. So what times 3 gives me 6? 2. So notice how I'm kind of switching. I'm kind of cross-multiplying. So that gives me 6. But that 2 also changes my potassiums, my Ks to 2, and my Cls to 2. All right, so take a moment before I give you this final answer. What can I change for my coefficient for KCl to fix my work. What times 1 will give me 2? Well, 2. And that'll fix both of them. And now it is a balanced chemical equation. And how do I tell? Because I can look at my numbers here, and I can see that they're the same on the left as they are on the right. That is a balanced chemical equation. Hopefully that helps you, how to use a chart. All right, we'll do one more. This one looks like it's really complicated. It looks like it's really long, but you will see that it's not so bad. Right? So following along, write in your elements. Pause the video and try this. You're going to put in iodine, sodium, sulfur, and oxygen. And the order down here doesn't matter as long as you have each element once and only once. Okay. On the left side, I have 2 iodines, 2 sodiums, 2 sulfurs, and 3 oxygens. On the right side, I have 1 iodine, 1 sodium. Oop, I take that back. I have 3 sodiums, 4 sulfurs, and 6 oxygens. Why do I have 3 sodiums? Because I have 2 plus 1. All right. Now I'm going to look and see what's balanced and what's not balanced. I see that my iodine is not balanced, my sodium is not balanced, nothing is balanced at all. So essentially, here I go, well, what is the easiest thing for me to fix? You can fix any element that you want at first, but I personally think that the iodine is easiest to fix, so I'm just going to try that. And honestly, I'm just trying right now. So let me go and change my color red. So I'm going to do 2 here because 2 times 1 gives me 2 iodine. But that also changes my sodium. I have 2 sodium here, and I have 2 sodium here. So 2 plus 2 is 4. Okay. So I'm going to undo something real quick. So I have 4 sodium. All right. And now I'm going to go in and I'm going to fix my sodiums. Okay. So I'm going to put a 2 here because 2 times 2 is 4. All right. That fixes my sodiums. But it also changes my sulfur. 2 times 2 is 4. It also changes my oxygen, which is 6. Oh, look, that actually helped those to automatically get fixed. Right? So I kind of fixed both things that mean for once. So that is now my balanced chemical equation. Good luck on balancing. These just take a little bit of practice. Once you get them down, you'll find that they're not too bad at all.